We are going to talk through structured data, chapter 11 from the Gaddis 9th edition C++ control structures through objects. And so we're going to talk about abstract data types, which is basically a data type that a user creates. And so values can be stored, operations can be done with the values. When you create an abstraction, it's a definition that captures the general characteristics without the details. So, So, for example, an abstract triangle is a three-sided polygon. A more specific triangle would be scalene, isosceles, and equilateral. Many times, an abstraction is going to be like a superclass, and then the details might be a subclass. The data type defines the values that can be stored in that particular variable and operation. We are going to talk about structures specifically. So a structure is a C++ construct that allows multiple variables to be grouped together. It's kind of like, I don't want to say it's like an array, but it's where you can access multiple variables of different types. They don't have to have the same type, whereas in an array, they all have to have the same data type. So this allows us more flexibility for creating arrays of structures, and it's a way that I can make an array hold multiple different data types if I wanted to, or a vector, for example. So the keyword that you use is struct. You have the name of the structure inside angle brackets, and then you have the data types and the field name. So here's an example. Student structure. So you have the keyword struct followed by the name of the structure. Please notice it follows the class naming. It's a capital letter. It's also called a structure tag. Then each of the data fields has its own data type. And then you have the name of those fields. And so think of this as like in a database. In a database, these would be each individual fields in a database, and it ends in a semicolon when you create the structure. The examples that you have in class will show this. When you declare a structure, note it has a semicolon at the end. Struct names are commonly begin with the uppercase letter, as I said, and multiple fields of the same type can be in a comma-separated list. I did not mention that before. When you define a structure variable, you define it with the name of the struct first, so for example, student, and then an individual, Bill, for example, or it could be Sam or Mary or my student or student one. But what happens in memory is the computer sets aside then space for all of these four instance fields. When you access structure members, you use a dot operator. So once the student was created, I could say, well, what's the student's ID? I could say student.studentID will input the student's ID, or I can use getLine cn student1.name or student1.gpa. So each of these is going to assign the values to student1, stu1 for student 1. And so the first one would assign a student ID, the next one a name, and the next one a GPA. It shows three different ways that you can use the dot operator to get values. Member variables can be used in any manner appropriate for their data. This is the example from the textbook, example 11-1, and we also have some of this code posted online. So study through that code, look at some of the different examples, look how they use the dot operator. So an employee.hours, this is setting the data right here, and then this is outputting the data. But you use the same, for example, employee.hours you use to input the data, and employee.hours to output the data as well. When you display a structure variable, you cannot just display the name of the structure. So you have to actually say, use that dot operator, dot student ID, dot name, dot year in school. The only way that you could do this is if you do some overriding of methods, which we may look at, okay? When you compare structure variables, you cannot just say, is Bill equal to William? You have to actually compare item by item or field by field. So you have to compare field by field in order to actually compare structures are equivalent. When you initialize a structure, there's a couple different ways to do this. You can fill the structure with the corresponding data, but you have to make sure that the data that you enter is in the same order as it's defined in the structure. If this order is incorrect, it will give you an error. You could also go by field by field. You have student S, you're going to assign the name. You're going to assign the GPA using the dot operators. So you can do what's called member by member definition, which is what I call field by field. You can initialize just one item, and then the rest of it will be a default value. But you can't skip over members. Like if you want to create student S, we have skipped over, I don't know what field we skipped over, but it looks like we skipped over whatever this field is right here, the 2. I don't know what that field actually is. If we scroll back up to see what a student or how a student is created, and it's not showing me there. Year in school. So we skipped over the year in school, and so that is not possible. You have to include all of them in order to do that. You cannot initialize in the structured declaration since it does not allocate memory. So that means when you're declaring the structure right here, there are no initializations. That's why you only see data type and variable name. Data type and variable name. Here's a couple of more examples of just creating an employee. And as long as this data is in the same order that it was set up in the structure, then you should be good. So this one does name, employee num, and then the pay rate. The hours and the gross pay aren't filled in because those are data that we'll get later in the program. You can create an array of structures. So I could create a number of students as 20, and then the student list. So this creates a student list of students. And so this is the data type for the array. So my array is going to have all students in it, which means I'm going to be able to access their student ID, their name, their year in school, and their GPA using these dot operators. This next example shows a structure that's a pay info. So we're switching examples. So it has 2 fields, 2 members, and it creates an array of workers that have the type pay info. And pay info is only going to keep track of hours and pay rate. So what's going to happen if I create my main, I have a workers, that's a pay info, and it's going to enter the hours worked by number of workers, employees, and their hourly rate. So this is just this right here is like a prompt. It's telling me what the whole program is going to do, and then I process through a loop, and I can use the bracket notation because this is an array. So worker bracket first index, worker bracket second index. So I get the hours for each one, and I get the pay rate for each one. And then it's going to display the employee's gross pay. So it goes through and calculates their hours times their pay rate. Notice the dot operators, workers index dot pay rate. So you can use these values and do mathematics on them just like we normally would. And this is what our output would look like. Notice this first line here was just our intro. This is going to get the hours worked by 3 employees and their hourly rate. So it does that. And then here's the gross pay. Notice this is what we talk about, having your input and your output clearly defined. I know exactly what's being inputted. I know what my output represents. Notice the number 1, number 2, number 3. So it's very clear what it's entering and what it is outputting. Nested structures are structures within structures. And so in this particular example, we have a person info with name, address, city. They're all strings, so I can declare them without repeating the keyword string. And then I have a student structure, which includes a student ID, a person's info, the year in school, and the GPA. So please notice that person info itself is a structure. And so person info is going to be a P data, and the P data is just an indicator. That's kind of a naming convention that they're indicating that we're going to be pointing to a person info, or we're going to basically use a structure within a structure. So when you do this, you can use the dot operator multiple times. So P data was like the personal data. So the student is S, I'm going to access their pdata, and what's in pdata is name, address, and city. So I use the dot operator twice. So s.pdata.name, s.pdata.city, and I can assign values that way, or I could access values that way for outputting. You're also going to be using structures with functions. So you can pass members of a structure using the dot operator. That would be a single item. Or you can pass the entire structure with just a structure name. You can also use reference parameters if a function needs to modify the contents of a structure. So you could show pass by reference here. If you use pass by reference, we'll have to take a look at an example of that. But here's an example of an inventory structure. And if I pass in an inventory item, so inventory item P, then I can output P dot, and I access all of its fields, all of its members. Okay. This also shows how to do decimal points to 2 decimal places here, fixed, show point, and set precision. When you're using a value parameter for a structure, you can slow down a program. It will waste space. Using a reference parameter will speed up the program, but the function may change the data in the original structure. Using a constant reference parameter allows read-only access to a reference parameter. It does not waste space, and it does not waste, and it helps with speed. Okay, so what they're trying to say here is if you use pass by value, which is what this program does, this example, it actually takes up more memory because you have to copy over all of this data. So it's copying all that data over versus pass by reference. So how do you pass by reference? You use the ampersand. And in order to protect the data, you use the constant keyword in front of it. So if you don't want somebody to change this, you can pass it by reference, but make it a constant so you can have the advantage of speed and less memory while also protecting the original data. So that's what that slide was talking about. If you want to return a structure, you can do that. You can create a structure in a method and return a structure. So a function can return a struct. So you could create a student, get student data, and what's going to happen is get student data is going to return a student. So student 1 get student data, for example, here. And so this is the prototype that has to be before main, and then the function call is going to be student 1 is going to get assigned get student data. The function must define a local structure. It's for internal use, and you have to use with a return statement. What that means is you have to declare a student locally. This is the internal student. You get all the data for the student however you like using cin or get lines. And then your year in school and your GPA. So please notice that they're using get lines when they're doing all of the string inputs. This is the preferred way to get string inputs. And they're just using cin for numeric input. So then you create your temporary student, you get all the fields for the temporary student, and then you return the temporary student. This is an example of, I believe, doing the same thing with a circle. So we're going to get info for a circle, and it's going to return a circle. So this is the return type, and this is the name of the method. So return type, name of the method. And a circle is defined with radius, diameter, and area. So if I scroll down, I want to go to the definition of get info first. You create a local circle, and then you enter the data for the circle, and then you return that circle. That circle gets returned to main, which happens right here. So they called get info, and that comes back to this local circle. Circle was declared here. And then I can access the area is pi times the power function, radius squared, and I can output that data. So that's just showing you how you can write a method to get info and return a particular item. Pointers to structure. Some of you might use this in your semester project. So a pointer to a structure variable has an address. Pointers to a structure are a variable that can hold the address of a structure. So this is a pointer to it's a student pointer, so it's a pointer to a student object. You can use the ampersand operator to assign an address. So a student pointer gets assigned ampersand student 1. And a structure pointer can be a function parameter, so you can send it in to a function. You must use parens to dereference the pointer, not the field within the structure. That means you don't use it on the dot operator, you use it on the name of the pointer. So student pointer gets dereferenced, which means you're going to access the individual value within that pointer. And you could also use the pointer operator to eliminate the parentheses. So if you don't like this notation, the following notation does the same thing. So student pointer arrow, student ID is the same thing as a dot operator. So these two lines are synonymous. And that's how you can output the value within a pointer. We'll do some other videos on pointers. What's nice though then is if I say get data and I pass in a student and I pass in a dereferenced or the pointer to a student, then I can just do use this pointer notation here, S arrow name instead of the dot operator. I think of this as S dot ID num, S dot credit hours, S dot GPA, but it's the notation that you would use with pointers. So instead of the dot operator, you use this arrow, the pointer notation. Enumerated data types will be covered in a separate video.